clear of information or data from unauthorized access. To achieve this, we are using the encryption algorithm. There are two kind of encryption algorithm, which include the symmetric and asymmetric algorithm. And uh, if the mentioned key pair is your, okay, for example, symmetric algorithm allow encryption and decryption with the similar key. If we use the asymmetric algorithm, you have two kind of keys, a public, or one key we say that are the public and the other key is the private. The public key is often available to the public while the private key is available for yourself. For example, if we discuss the example like bank account statement, personal information, credit card number, trade secret, government document, everyone has the information they wish to keep a secret. Protecting such information is a very major part of information security. If we move to the second part, but currently as our lecture we are discussing the cryptography and network security lecture series. We are in the portion of confidentiality, but here in the CIA trade, I briefly explain the integrity and availability part as well. Integrity is used to make sure that nobody is between the sender and receiver. For example, change some part of share information or protecting information from being modified by unauthorized party. Therefore, a hash is calculated and added a packet. This can be achieved by using the hash algorithm like MD5, SHA-12, 128, 256, and so on, to really make sure that no one is even able to modify the hash MAC. Hash MAC is used. This stands for hashed message authentication code. For example, information that has been tampered with could prove costly. For example, if you were sending an online money transfer for $100, but the information was tampered in such a way that you actually sent $10,000, it could prove to be a very costly for you. As with the data confidentiality, cryptography play a very major role in ensuring data integrity. Commonly used method to protect data integrity include the hashing of data you receive or compare it with the hash of the original message. In our next lecture, we will move forward to the confidentiality, to the different integrity algorithms. Third portion is the CIA trade is the availability. Availability of information refer to ensuring the authorized party is able to access the information when needed. Information only have a value if right person can access the information at right time. Denying access to information has become a very common attack nowadays. Every week you can find a news about high profile website have been taken down by DDoS attack. The primary aim of DDoS attack is to deny user of website access to the resource of website, such as downtime can be very costly. Other factor that could lead to a lack of availability to important information may include incidents such as power outage or natural disasters such as floods. Uh, Cryptography play a very crucial role to protect sensitive information by transferring it into unreadable format. We say that encryption, and only the authorized recipient can be able to convert into the original information. It comprises different mathematical processes involved. Encryption was designed to secure from unauthorized access. Unfortunately, the development of fully secure cryptographic algorithms are difficult due to the existence of challenge from the cryptanalysts who continuously try to assess the available crypto system. As the rapid growth of internet and other form of network communication become more dominant, it is challenging task to understand how to systematically recognize and address the information security risks and take steps to understand and manage these risks. A vast range of applications are made to secure the cryptographic algorithm. To achieve the high security requirement, highly protection from the cryptographic component to cryptanalysis are required. Furthermore, every cryptographic algorithm need to fulfill the execution time test and validation will be considered as approval with the advanced encryption standard and other algorithm. Now we will move forward to the non-binary block cipher. Actually, the non-binary block cipher is the alternative cipher which uses the ASCII decimal as representative of message encryption and decryption key and the ciphertext. The development of non-binary ciphers such as TOY 100, DEANS 18, a large block cipher involving a key applied on both the sides of plain text, and the pyramid block cipher provide an alternative to an existing block cipher such as Rendiel, Tawfiq, or cipher different algorithm. In computer science research, adoption of three-dimensional structure such as cubic in grid computing and magic cube toy is the design of image encryption algorithm has inspired this research for creation of permutation element for non-binary block cipher. Permutation of a finite set of number or symbol play an important role in the development of block cipher. In similar transposition cipher, permutation is used to mix up symbol or number to create a ciphertext. The technique preserves the number of symbol or number of given type within the block cipher, which make it easy to analyze the cryptanalysis if the block size is small. So in this regard, the development of efficient computer hardware and software which makes permutation only algorithm more prone to attack by cryptanalysis. Modern binary based cryptographic algorithms such as combination of substitution and transposition are used to enhance the complexity of the ciphertext. Substitution creates the confusion in the ciphertext to avoid attacks such just to applying simple permutation of symbol to get the encryption and decryption keys. Substitution box, or in other words, we normally use the S box, are used as a confusion element in Rendiel and Tawfiq algorithm. Whereas if we look out the second parameter, second function, which is the diffusion function, in which the binary cipher such as the maximum distance separatable MDS and pseudo Hadamard transformation are used in Rendiel and Tawfiq respectively. In the meanwhile, if we see that the high C implementation explore the possibility using the decimal number in the development of non-binary block cipher, which incorporate the following study such as the Latin square, orthogonal Latin square, magic square, triangular magic cube, and magic cube transformation. And if you see that TOY 100, DEAN 100, and a block cipher. Here we see that the overall design of hybrid cube. In first portion we see that how the hybrid cube is created. Then later on the next part we see that how the algorithm are designed or developed using the hybrid cube encryption algorithm. At first portion, if you see that the overall design of hybrid cube of order 4 is depicted in this figure, the framework for creating the hybrid cube. Based on the figure, a series of permutation and combination of set of integer 1, 2, 3, 4 are used as a foundation of conducting all the 576 latent square of order 4. All these latent square are used to construct 3456 pair of orthogonal latent square. The existence of 880 magic square of order 4 was available. Also, the adoption of triangular formulation where construct the magic cube which layer entries fall in the set of integer 1 to 64 entries. Using this magic cube, Hi-C research developed a new cube structure called the hybrid cube, where the layer entries are between the 1 to 4096. In the second part, we see that the how they generate the hybrid cube encryption, hybrid cube using the magic cube and vice versa, and the other side here we see that the how the hybrid cube encryption algorithm is work. First step in the development of Hi-C is to generate the hybrid cube, as we see here, which is the main element in the construction of key scheduling algorithm, encryption decryption algorithm. Hybrid cube is generated by using the inner matrix multiplication of two magic cube to ensure all matrices generated from the hybrid cube are invertible. The second step in the construction of key table in the key scheduling algorithm using the matrices generated from the hybrid cube. The third step is the message from the sender is encrypted using the encryption algorithm to generate the ciphertext. Finally, the final step of Hi-C is to develop the ciphertext using the decryption key generated from the key scheduling algorithm in order to get the original message on the receiver end. That are similar to the sender have sent to the receiver. This is what the general structure of hybrid cube encryption algorithm. Now we come here is that by the generation of hybrid cube, a non-binary block cipher, we say that we are working for the development of key scheduling algorithm for the hybrid cube encryption algorithm. The encryption algorithm in this research, the hybrid cube algorithm is adopted as a platform in order to validate the proposed key scheduling algorithm. For your information, Hi-C is designed the key scheduling algorithm, but in our research, we say that Hi-C using KSA-HC algorithm is the further improvement in the Hi-C encryption algorithm. And we are using the platform of Hi-C encryption algorithm by development of new key scheduling algorithm. After that, we have integrated the key scheduling algorithm, or we say that we embedded the proposed the new key scheduling algorithm using hybrid cube with the Hi-C encryption algorithm that is used to generate the key SAC algorithm to encrypt the message into a ciphertext. Hence is the symmetric non-binary block cipher because the encryption and decryption key, plain text, ciphertext, and internal operation in the encryption decryption that is based on the integer number. The plain text size of the encryption algorithm is the ASCII character of 64-bit, as we discussed earlier. The initial matrix here is used during the encryption decryption process is the secondary security measure which ensure the authenticity of the user. The master key generated from KSAC algorithm, here we use K1, K2, K3, K4 to encrypt the message using these keys. The process of diffusion is performed using the mixed column and mixed row operation adopted from TOI 100 algorithm to strengthen the ciphertext. Here is the graphical representation of the encryption algorithm. On the other side, you will see that the decryption algorithm, which is the reverse engineering of encryption algorithm, in which we receive the ciphertext from the sender and the secret key, because we are working on the symmetric algorithm. So in this case, we use similar key of the encryption to decrypt the message from the user as a requirement of reconstructing the message back to its original form. This is what the about the high C encryption algorithm, how we design the KISAC algorithm, KSAHC algorithm. So in the next video, we will see how we design the KSA algorithm after the generation of different encryption key and decryption key using KISAC algorithm. We integrate these keys with the high C algorithm. So in kindly watch our next video where we will discuss how the key scheduling algorithm that generate these key that used in the